Okay, good evening. Welcome to
Minute Math number 7.
Minute Math number 7. These are some fun problems that the American Mathematical Association is putting out, and sorry the lighting on this one isn't so good. We had some trouble with our lights today. So, ABCD is a square, and BEF is an equilateral triangle. So let's talk about what that means. What does it mean that this is a square? What are some things that we know about squares?
All four sides are equal.
All four sides are equal. Awesome. What else do we know about squares?
We know that all the sides are right angles.
All the sides meet at right angles. So this is a right angle. This is a right angle.
And purple.
This is a marker that doesn't work. And that's a right angle. So, okay, great. What does it mean that this is an equilateral triangle, BEF?
It means that all three of the sides are the same.
These sides are the same. Do you remember what the angles are in an equilateral triangle?
60.
Right, these are 60-degree angles. That doesn't come into play in the problem, really, but it's a good thing to know. So what we're asked to find is the ratio of the area of triangle DEF to ABE. So this triangle to this triangle. Okay? This is a special kind of triangle. This is called an equilateral triangle. And the reason is pretty neat. The reason I know that this side and this side are the same. Any guess?
Well, the sides of the square are the same.
Well, yeah, but this side stops here. The side of this triangle stops here, and the side of this triangle stops here. The reason they're the same is because this is an equilateral triangle, and there's a lot of symmetry in this problem here. So that means this 90-degree angle has a 15-degree angle here, a 15-degree angle there, which makes this a 75-degree angle, and which makes this a 75-degree angle. So there's a lot of symmetry in the problem. You can draw a line like this. And everything on this side of the line is the same as on that side of the line. So that means this side and this side are the same. Okay? So how do you solve a problem like this? This is a tough problem. Okay? You ready for some neat stuff?
Yeah.
We don't really know anything about what's going on here, right? So one thing we can do is just say, well, okay, let's try to simplify the problem. Let's try this, call the side of the square 1. Okay? And let's call the side that we don't know, let's just call it x. Okay? Alright?
Yeah.
If this side's 1 and this amount is x, how long is this amount here?
It's 1 minus x.
1 minus x, very good. Okay? Now we have two right triangles. Is there a special theorem that you've learned about right triangles? That a guy named Pythagoras invented?
The Pythagorean theorem.
Do you remember what the Pythagorean theorem says about right triangles? If you have a triangle, a right triangle, and the sides A, B, and C?
No.
Remember? It says that A squared plus B squared equals C squared. Okay? So in this right triangle here, FDE, that tells us that x squared plus x squared is the side of the equilateral triangle. Let's just call it y. It's y squared. Okay? And for this triangle, EAD, the Pythagorean theorem says 1 minus x squared plus 1 squared equals y squared. Well, that's interesting. So, in other words, 2x squared equals 1 minus x squared plus 1. Does that make sense?
Plus 1 squared,
plus 1.
That's 1.
Right. So 1 minus x. Okay, so now we have a nice little equation involving x. Okay, so we can solve this equation. 2x squared equals 1 minus 2x plus x squared. That's 1 minus x squared plus 1. I bring the x squared over to this side. What is 2x squared minus x squared?
2x squared minus x squared is 2x squared minus x squared is x squared.
Right, x squared equals 2, 1 plus 1 minus 2x. Okay, that's interesting. Okay, so we actually have an equation for x, and we don't really know what we're going to do with it, but we have an equation. What we're trying to find is the ratio of the areas of this triangle. You remember how you find the area of a triangle? 1/2 base times height. You remember that?
Yeah.
Yeah, 1/2 base times height. Well, in right triangles it's really easy. It's 1/2 base times height. So we're trying to find the ratio of 1/2 x times x divided by 1/2 base times height. In other words, the 1/2s cancel, and we're trying to find the ratio of x squared divided by 1 times 1 minus x, which is just 1 minus x. Okay? This is what we're trying to find. This is what makes this a really neat problem. Okay? We know we have an x squared here. It would be great if we could get a 1 minus x on the bottom. Well, x squared equals 2 times 1 minus x. That was from our equation before. Now I divide everything by 1 minus x. And I get x squared, probably out of the camera, 1 minus x, I hope I'm not,
Okay.
equals
I'll
2.
check.
Yeah, can you go check? Is my hand on the camera here?
Just barely.
Oh, okay, good. It turns out, miraculously, that x squared over 1 minus x equals 2. So the ratio of this triangle to this triangle is 2. In other words, 2 of this triangle equals that triangle. But we have 2 of those triangles. Isn't that interesting? We have this triangle plus this triangle equals that triangle. It's pretty neat.
Yeah.
It's pretty neat. This is a very, very hard math contest problem. You probably have to be a lot older to solve this one on a math contest. But what did we do to solve it? We found some general properties of squares and equilateral triangles. We labeled x as one of the things that we didn't know, and we tried to find some equations that x solved, and we found some. And we ended up figuring out the whole problem from that. Isn't that cool?
Yeah.
Notice we never figured out what x was. We don't know what x is. It might be 7, it might be 10, it's probably not 7 or 10 because the whole side's 1 and it's less than 1, right?
Yeah.
But maybe it's a half, or maybe it's a third, or maybe it's a fourth, or maybe it's like the square root of 3 divided by 7. We don't know, but we never needed to know what x was. That's the amazing thing. All we needed was this ratio, and we found that that ratio was 2. Pretty cool.
Yeah.
Think you'll be able to solve a problem like this someday?
Maybe.
Maybe. I bet you will. Alright, good job.